Hello, welcome to Virtual Shahan Academy, and I'm Professor Shahan. And I would like to teach you today how we can balance the equation in the acidic medium from ion electron method. So let's get started. Thank you. If we would like to balance the equation which is in acidic medium, so how we can take steps? So there's four steps. First one is separating the equation into two half cells. First of all, you have to separate the equations into oxidation cell and then into oxidation cell. And the second one after that, you just balance the atom. Third in the step, you just balance the charge. And the fifth step, you just balance the electron. And at last, in the concluding stage, at the very last, you just combine all and the equation, and just we see there, focus on the equation, either it's a balance or not. Okay, so let's get start. So first have a look. First we will make a charge. Okay, so what is the charge on chrome? This is a dichromate ion. Basically, it is a dichromate ion, and we just for finding our oxidation state. Oxidation state. How we can find our oxidation state? Basically, we know that it's a twice atom of the chrome. So we just suppose chrome the x value x. Okay, plus we know that the value of oxidation state of oxygen is 7. Okay, so we just multiply by 7 by 2 minus 2, or oxidation state of oxygen is minus 2. Okay, so we just multiplied the its valency, and then these all is equals to minus 2. Minus 2 is basically the ionic charge, so it is all it's equal to minus 2. So what it becomes, it's minus 14. Okay, become minus 2. So when 14 go to the right side, so it become positive 14 minus 2, it become positive 12. So when 2 becomes divided, so what is the value? So x is equal to positive 6. So means here is the ionic charge of chrome on chrome is positive 6. That of as you know, the charge on oxygen is minus 2. Here is positive 2 charge on iron, positive 1 on the hydrogen. Chrome already shown, plus 3. Iron is already shown, plus 3. The charge on hydrogen is a minus plus 1, and the oxygen, you know, minus 2. Okay, so after this is not the steps. It is first finding your oxidation state, and then you just separating the basic two halves. Okay, the first step one. Now I am going to start step 1. Okay, the our step 1 is step 1. Okay, and separating half cells into half cells. Okay, it is our oxidation. What is the oxidation? Oxidation is the, what is the oxidation? Oxidation is the loss of electron. Okay, gain of hydrogen. Reduction. What is the reduction? Reduction is the gain of electron and loss of hydrogen. Okay, so loss of electron, gain of electron. Okay, so what is the oxidation? You just focus on that. Which atom gains, which ions or which atom gains electron, lose electron? Here you see that the positive 2 charge on ion, it must be loses its 1 electron from its octet, so that's why it becomes positive 3. So means this is in the oxidation state. So we just separate out from that. We extract from this equation and just prescribe on that. And here is chrome. Chrome is positive 6, and now it is in positive 3. It's positive means they gain 3 electrons. Gain means it is in the reduction state. Cr2O7 minus 2, which is Cr positive 3. Okay. Okay. Now what we have done? What we have done? we have done the first step. Okay, now balancing the atoms. Now we just balancing the atoms. Okay, the step 2 is balancing the atoms. It's step 2. Okay, oxidation, in the oxidation state, this is already balanced. It's one atom. It's one atom. Okay, and now we go on the reduction state. In the reduction state, chrome is positive 2 and there is simple 1. So we just multiply by 2. Okay? Chrome is balanced. But 7, oxygen is 7. So we just add water. Okay. Why we add water? Why we add water in spite of adding oxygen alone? We didn't add oxygen alone there because this is in the aqueous solution. This all is happening not in air. This all is happening in the aqueous solution. So how we can add the air? We just add water. Okay. So but as soon we add water, so hydrogen become 14. So we just add the left side 14 H positive. Okay. So it balance, hydrogen balanced, atoms of all atoms is balanced. Chrome 2 chrome, oxygen 7, 14 hydrogen. Okay, hydrogen 14. So this is what we have done. We have done step 2. Now we have to go on the balancing the charge. So let's balancing the charge. This is our 3 state. Balancing the charge. Okay, this is our 3rd step. So balancing the charge. The charge is 2 on the oxidation state. On iron, charge is plus 2. So we have to manage plus 2 or plus 2. So we add, what we add? We just add 1 electron minus to 3. So it becomes plus 2. So plus 2 balance. In the reduction state, what we have done? We just done electron. So we have to balance the charge. Okay. The charge here is 14 on the left side of the reduction state. The 14 plus and minus 2. So 14 plus minus 2, when we add up on, it becomes 12 plus. 12 plus charges. So here 2 multiplied by 3, 6 chrome. So we intentionally add 6 electron minus on the right side. So now, sorry. So we just add 6 electron on the left side. So why? When 6 positive get plus with the 6 negative, so it answer becomes 6 plus, or 6 plus on the right, 6 plus on the left. So it becomes balanced. Okay. So means we have what we have done it. What we have done? We have done the 3rd step, and now move on the 4th. Okay. The last step, basically, the last step of is the ion electron method. The balancing the electrons. Okay, balancing the electrons. This is the last step, and after that we will just sum up the both of the cells of the this aqueous solution. Okay, let's move on. What we seeing here in the 4th step, the balancing electron. In this all the scenario, what you see in this all the scenario, it's all the scenario. There's 6 electrons, okay, and there's only 1 electron. So when we multiplied it with the 6 all, so how it become? Fe plus 2, Fe plus 3. Why we multiply with 6? Because we just want to balance the electrons in the left with respect to reduction state. In the reduction state, the equation have 6 electrons. So now in the oxidation state, it balanced by this electron. So means when we both cells have the same electrons, both cells, oxidation cells and reduction cells, should have same electrons, which basically is the theory of balancing the electron. Okay. So now Now we will go to the balance. Okay, now we just have done all the steps, and we will just balance here, and we have done the fourth step, and now we just write the equation on right there. Okay, the balance, this is the unbalanced, and now we are written the balance. Okay, what is the balance? Cr2. Okay, we just add up oxidation reductions both. Fe6 plus 2, okay, add it with this equation, with added this reactant plus Cr2O7 minus plus 14H plus 6 electron minus. Okay, and all the things should be added. You just added all of those stuff on the left, and you should add all of the stuff on the right. Okay, 6Fe plus 3 plus 6 electron minus plus 2 coulomb plus 3 plus 7H2. Oh, okay, now we just rub it. So what we have, what will be next? So you just focus on that. 6 electron becomes cancelled out from each other, from left side and right side. Okay, so what will be on the last? 6Fe plus 2 plus Cr2O7 minus plus 14H plus 6Fe plus 3 plus 2 coulomb atom and 7H2O. It is the balance. Okay, this is the balance. Here you see that if you see the atom of iron, so where is iron? Iron is 6, iron is 6. Okay, balanced. Chrome is 2, chrome is 2, balanced. Hydrogen is 14, hydrogen is 14, hydrogen balanced. Oxygen 7, oxygen is 7, oxygen balanced. Okay, and now move on the charge. We will talk about ions and charge. Why? This is because the iron electron metal. We have to balance the ion and the equation and atom. So what is the ion? Iron is the total worth of charge here is iron plus 2 or plus 12. So 2, 12. Okay, 14 plus 14. Okay, and minus 2. Basically this is minus 2. Okay, so minus 2. When we just sum up, so it becomes positive 24. So there should be positive 24 on the right side. So we see it's 18 plus and it's 8 and 6 plus, and there's neutral 0. So what is this? 24 means charge is balanced, atom balanced. So it means you have the managed how to balance the equation with respect to ion electron metal. So this is our lecture, and hopefully we will see you in the next topic. Thank you.